Hi, in this video we will quickly review the telescoping series. For this special series, you can see that nearly every term cancels with a preceding or the following terms. For example, I have this series. The index go from 1 up to infinity. 1 over 3 to the k, subtract 1 over 3k to the plus 1. Now, if I rewrite this term out, when the index k becomes 1, then I have 1 over 3. 1 plus 1 is 2, so I have minus 1 over 3 squared. This is only for the index k equal 1. Now, if I add it, because this is the sum, and the next one is for the index k equal 2. So 2 go to here, and 2 plus 1 is 3. So this is the sum for the first two terms of the index k equal 1 and 2. Now if I keep going to the n terms, then the k become n, because this is the n terms, and k also become n plus 1. And as you can see, the we have the 1 over 3 square and plus 1 over 3 square. So all the term in the middle, 1 plus 1 minus, they should cancel out, right? This one and the next one, they should cancel out. So they should cancel out. So at the end, all you get is just the first term, and the last term remain after you sum them up all together. So finally, the sum of infinity, the limit is infinity. K go from 1 and 1 over 3 to the k power, subtract 1 over 3 to the k plus 1. Now at the end, all you get from here is just the first term, 1 over 3, and which is also the last term, minus 1 over 3n to the plus 1. Okay, this is the n term. So when you add them all together, you should get the first term and the n term. Now, because we want the limit of n to be approaching to infinity, this should equal to the limit of n approaching to infinity, because we have the infinite sum. So you should include the limit of n approaching to infinity. And if we do that, we should take the limit. Now, the 1/3 for the first term doesn't involve the n, so the limit for n approaching to infinity of 1/3 is the same thing, 1 over 3. Now we have to bring the limit to the second term. The limit of n approaching to infinity of 1 over 3n plus 1. Now, as n approaching to infinity, infinity plus 1 is infinity. 3 to infinity is infinity. 1 over infinity is 0. So this whole thing here is 0. So at the end, you just get 1 over 3 for the infinite sum of this special telescoping series. So you remember that for the telescoping series, all the terms in the middle, they all cancel except the first term and the last term. And you may also recognize that usually for the telescoping series, we will have two fractions here, and the side here should be minus, because you want the minus and the plus, they cancel out. So the middle, the side in the middle should be a minus for any telescoping series, and you have the two fractions. So keep that in mind. Because why? Because we have this problem. This one. Find the sum. Find the sum of the infinite sum from n equal 1 up to infinity. Now, we cannot find a sum. There's no formula for the sums. But if you can convert this one into the telescoping series, then you can find a sum just by adding the first term and the n term, taking the limit of the n approaching to infinity. So can I convert this one to a telescoping series? Okay, go back to the telescoping series. Remember that for any telescoping series, you need the two fractions, and the sign in the middle should be minus. That means that we need the partial fraction of this one, and to check if that is the telescoping series or not. But the first step here is you have to break this fraction into the partial fractions. Okay, just to make that easy, I bring the 7 to the front of the sum. So keep the 7 to the front, so we don't have to deal with a large number. So I bring the 7 to the front. I should have 1 over n plus 3. Okay. Now let's just focus on this thing. So find the partial fraction of that. Okay. So let's find the partial fraction, and then at the end we just multiply the 7 in. Okay. Okay. So I have the 2 factor at the bottom. So I have n here, and I have n plus 3. One has a constant a, the other one has b. Adding together should equal to this whole thing. Okay. Now, what is the LCD for all of them? The LCD should be the product n and n plus 3. Right. Now, after that, we take the LCD. We multiply the LCD on both sides. So I multiply to the left side n plus 3, and then I multiply that to the right, the left hand side, n plus 3. Okay, and then make the distribution to the left side. Okay, when you do that, the first term n and n, they cancel out, so I have a n plus 3. The second term, when I multiply the LCD, n plus 3 and n plus 3, they cancel out, so I only have n, so bn. And then the right hand side, this is the LCD, so that we cancel all of that, so I get 1. Now make sure we simplify that. A times n is an, plus 3 times a is 3a, plus bn equal 1. Okay. The variable here is the n, so we have n and n. Let's combine the n together. So we factor out the n. You should have a plus b. Right, I pull out the n. And then we have a constant 3a equal 1. Now, because we have the equal sign here, that means the left hand side and the right hand side is equal. We see that this is the variable n. We don't have any n here. That means the coefficient of that n should be 0. So 1 is the same thing as 1 plus 0 times n, right? Because 0 times n is 0. 0 plus 1 is 1. So in front of the n, the coefficient is 0. That means a plus b has to be equal to 0. And then this is the constant. The constant and the constant, they have to be equal. So 3a has to be equal to 1. So this is the requirement for you to solve for a and b. Because we need a and b here. So it's easy. You can solve for a, divide by 3 on both sides, right? You get 1 over 3 for a. Once you get a to be 1 over 3, you can use this equation to solve for b. What a now is 1 over 3, a plus b equals 0, so subtract 1/3 on both sides, b equals minus 1 over 3. Okay, so we got a and b, so we should plug a and b to here. Okay, so I should get a is 1 over 3, so 1 over 3 n, and then b is minus 1 over 3 n plus 3. Okay, so the whole sum right here, remember we need the sum, right? The whole sum, the partial fraction, I can break it down into these two partial fractions, and now I rewrite this way. And don't forget that this is the sum of n go from 1 up to infinity, right? It's from here, and up to 1 up to infinity. And don't forget the 7. Now it's time for me to to plug the 7 back here. Okay, so we are able to break down the infinite sum into the sum of two fractions, because I told you before, for the telescoping series we need to get the sum of two fractions, and in the middle there should be a minus sign, right, so that the minus and plus they cancel. And now you see back here we have the minus sign, we have the two fractions, so it's look like that this series is a telescoping series, but we're not sure yet. You have to check that. Okay, so I need to check this series. Let's just keep the 7 in the front, because multiply by 7 is just a constant, so it doesn't matter. You can multiply that later on. Okay, so let's check this one, if this is a telescoping series or not. Okay, we can do that very simple. Okay, so keep in mind that we have a 7 in the front. We multiply that at the end. So when the index n equal 1, when n equal 1, I plug in 1 for n. So I get 1 over 3 times 1 is 3. Okay, minus 1 plus 3 is 4. 4 times 3, that is 12. Okay, so this is the first term when n equal 1. Now when I increase n equal 2, 2 times 3, that is 1 over 6. 2 plus 3 is 5. 5 times 3, 15. We still don't see the terms, they cancel, so we keep going for a few more terms. When n equal 3, 3 times 3 is 9. 1 over 9. And 3 plus 3 is 9. 9 times 9, 27. So minus 1 over 27. Still not. Just keep moving on. Actually here there's one more thing we can simplify. Let's simplify this. This is getting large. The number is getting large. So I want to do one more simplification here. Okay, from here. So we keep 7. Now you see that there's a 3. There's a 3, 1/3. I can pull out a 1/3 out the summation notation, right? So we have 7 or stay here before. So now I can pull out the 3, make it smaller. So I can pull out the 3, right? So inside the infinite sum, I should get 1 over n minus 1 over n plus 3. This looks much easier. Okay, let's try from here. So from here, all right, so we keep 7 over 3 outside. Okay, so the first term is 1, so it's much easier. And then the next one, you just add 3 more to that, right? So 1 plus 3, that should be 4. That is for n equal 1. Now add to the next one is n equal 2, and then 2 plus 3, that is 5. Right, the next term, n equal 3. 3 plus 3, that should be 6. It's much easier. That's why I factor out the 3, so that you don't have to multiply by a large value. Okay. And then the next one is the n equal 4. 4 go here. 4 plus 3, that is 1 over 7. And then the next one, n equal 5. 5, 1 over 5. And minus 5 plus 3 is 1 over 8. Now you can see that starting from the fifth term, 1, 2, 3, 4, the fifth term, the minus 1 over 5 is cancelled right here. Okay, let's keep going and see what's going on. The sixth term, 1 over 6, and 6 go here. 6 plus 3 is 9, or 9. You can also see 1 over 5 cancel with this guy here. 1 plus 1 over 6 also cancel with minus 1 over 6 right here. Just keep going. N equal 1, 2, 3, 4, 5, 6. How about 7? 1 over 7 minus 7 plus 3, that is 10, right? So all I do now is 6. Okay. you see that this is 1, 2, 3, 4, 5, 6, 7, and keep going. And this is from 4, 5, 6, 7, 8, 9, 10, right? So all you see now is this is 1, 7, go up to one more 8, 10, go up one more 11, and then 8 go to 9, 11 go to 12, and then so on. 9 go to 10, 12 go to 13, and so on. Okay, and now you can, and it just keep going forever. And you can see that minus 1 over 5 is cancelled with plus 1 over 5 right here. 1 over minus 1 over 6 also cancel out with plus 1 over 6. Minus 1 over 7 also plus 1 over 7 is right here, right? And then 1 over 9 plus 1 over 9 minus 1 over 9, minus 1 over 10 plus 1 over 10, they cancel out, they do cancel out. Minus 1 over 8 plus 1 over 8, they do cancel out, right? And so on. 1 over 4, this is minus 1 over 4, they also cancel out, right? And so on. So you see that all the terms are cancelled. All the terms are cancelled. They cancel. And then if you keep going, these two terms will be cancelled. These two terms will be cancelled with the next few terms. And we see that from this series, except the first, these three terms, they don't cancel. They remain after we add all of the sum. Right? All the other terms are cancelled. They all cancel. If we just keep adding more terms, they cancel. But except the first term of the first three index, 1 over 1, 1 over 1 half, 1 over 3, they don't cancel. They remain there after we add the infinite sum. Therefore, the sum of everything, the whole series, at the end, it's just that we take the sum of these two guys, 1, 2, 3, we multiply with 7 over 3 outside to get you the sum. Okay, so let's try. We have 7 over 3 outside, right? We keep that outside. We have 1 over 1, which is 1 half, and 1 over 3. Okay, so if you add them together, let me do a quick calculation here. 1 plus 1 half plus 1 over 3. If you convert that to fraction, you should end up, this whole thing here is 11 over 6. So we give 7 over 3, multiply 11 over 6. And now, to get the final answer, we multiply across them. 7 times 11 is 77. 6 times 3, that is 18. So the final answer should be 77 over 18. So this is a telescoping series, but it is special in a way that you don't see that they cancel right away. You have to write out 1, 2, 3, starting from the fourth term, then they fully cancel out all the term after. So after the 4 index, they cancel out completely the 2 terms, the 2 term, 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 the 2 term. Except the first 3 index, n equal 1, n equal 2, n equal 3, they only cancel out the second term, the minus term. The plus 1 remain after we add all the sum together. That's why we take only 3 of them, we add them together. We multiply with 7 over 3 outside of the sum that we had earlier. And that together, we should end up with 77 over 18. So in this case, pay attention. Sometimes that you have to write out not only the first 2 or 3 index, but 5 or 6 or 7 to see the patterns and see what we can cancel out. Okay, so that is how we find the sums of the telescoping series. So there's really not any formula. You have to to write out the terms, and if that is the telescoping series, we take the terms that are not cancel out, we add them together. Now, one more thing to pay attention here. Before the example in the class, you see that for the telescoping series, they cancel out all the term in the middle except the first term and the end term. But in this example, you can clearly see that they did not have that same patterns. They cancel all the term in the middle, but not the first term and the last term. The first term, the first three term was the first factor. So do pay attention here. They do cancel out all the term, but it is not always the first and the end term as you saw earlier. So depend on the series. But in general, for the telescoping series, they will be cancel out for most of the terms except a very few terms that remain after we sum all the series. But we don't know what exactly the term should be. So maybe the first term and the end term remain after we sum them up all together. Or in this case, the first term of the first three index remains after we sum them together. So it depends on its problem. Okay, so thanks for watching.